Hey everybody, welcome to Practical Alchemy. Today's episode is going to be a walkthrough on V-carving using Fusion 360. So if you have never used Fusion 360 to V-carve before, I think this is going to be a great tutorial for you. I'm going to be showing you how to create your artwork. I'm going to be showing you how to set your toolpaths, and then we are going to be moving over to the CNC machine, and we're actually going to be making our project. And for today's project, I have designed a very simple tray for your safety glasses. I don't know about you, but I am always putting my safety glasses down in random places that I almost immediately forget. So I am going to be executing this and using it immediately down in the shop. All right, so I am going to delete all of this out of my file, and we are going to get started. Walking through the steps, the first thing that we need to do when we are creating a V-carve is setting up our file. Now there's two things that I want you to pay attention to. Number one is the document settings here. All right, now I'm going to be working in inches for this particular project. So just make sure that your document is also set to inches so that you can follow along. The next thing that we need to do is set the direction of our primary axes, meaning the direction of our X, our Y, and our Z axes. So what I want you to do is come up here and go to your preferences, and under the general tab here, I want you to set your default modeling orientation to Z up. That is the way that winners do it. All right, so now, why do we do that? Number one, I think that is a more common modeling method. If you're using, for example, Blender or also SolidWorks, that's the way that that's going to be oriented. And I also think that makes the most sense when it comes to CNCing, because at least my CNC machine, the Z axis is the up and down axis, and the X and Y axis are the forward and back and left or right axes. So we want to make sure that all of that lines up. All right, now, step one complete. Document is set up. The next thing that we're going to need to do is we are going to need to create a workpiece. That is essentially the finished dimensions of your final piece, all right, in a rectangle. So what we're going to do here is I'm going to create a sketch, and I am going to put that sketch on the top plane. Next thing that I'm going to do here is to create that workspace. I'm going to create a rectangle. I'm going to use a center point rectangle, and I'm going to put that center point right on the origin and drag out. All right, now I'm going to define my dimensions very quickly. So for this piece, we are going to use a piece that is 6.5 inches wide, and we are going to use 3.5 inches tall. Now, one thing that I want to make clear to you guys as we're setting this up is that this bounding box should not be the raw dimensions of your wood that you're going to be carving, but it is going to be the finished dimensions of your final piece. Now, even if you are going to be routing a different shape, for example, an ellipse, right, you are still going to be just defining this outer bounding box first. And I'm just going to undo that really quickly. Okay, great. So always starting with that bounding rectangle with our center at the origin point. Next, I'm going to hit finish that sketch, and I am going to extrude this up. Now, a good rule of thumb for this, especially as you're getting started, is to set that to the thickness of your workpiece. So for my example, I'm going to use a workpiece that is 0.375 inches thick. All right, and that is now going to be essentially the block of wood that I'm carving. Step two, complete. Next step, we need to have some two-dimensional artwork to actually do our V-carve. We are going to be placing that artwork on the surface that we are going to be carving. In our case, that is going to be the top surface of our workpiece. So I'm going to go in and I'm going to create a new sketch, and we're going to place that on the top plane. All right, and now we're just going to orient ourselves normal. What we need in order to successfully execute a V-carve, and I'm going to go ahead and turn the bodies off. I'm going to hide those very quickly just to make this easy, is you are going to need not just any geometry, but you are going to need a closed path. What do I mean by that? All right, so I'm going to grab the line tool here, and I'm just going to click 3 lines. Okay. Now it should be pretty obvious to you that this is not a closed path, right? There's no volume here, right? There's just 3 lines. But if I click and drag this over to create a triangle, now I have a closed volume. There's 2 ways that you can tell whether your volumes are open and closed right off of the bat. Number 1 thing that you'll recognize is that you will no longer have the open endpoint handles here once your object is closed. Coincident constrained endpoints that are closed do not show the end handles. The other thing that you'll notice is that you will be able to click in that shape and it will be isolated from the rest of the geometry. All right. Now, in order to have to V-carve a shape, that geometry needs to be closed. It needs to have an outside and it needs to have an inside. Now, this seems pretty easy as you're starting off with some simple shapes, but as things get more and more complicated and these things get really, really close together, or if you start importing other geometries, or maybe you just have these constraints turned off, that is going to be a little bit more difficult to be able to visualize. So if you ever need to check or find an open endpoint, there's a quick and dirty way to do it, and that is to just create a line and drag it across your object. And what you can see now is that I can tell which part is open and which part is closed. All right, and what I can do is I can just kind of continue to drag that around until I can really start to isolate which of these endpoints is the open endpoint. And then as I get closer, now I can zoom in and it becomes much easier to identify. I'm going to go ahead and delete this sketch because I don't need that and start again fresh. So let's go in and create a new sketch. You're going to select the top face, and now let's go ahead and start doing some simple modeling. All right, so what we're gonna do is come up here and project these curves so that we can select the 4 endpoints here. And I'm gonna hit OK. I'm gonna hide this body. And so now I've got this as my starting box. Okay, and now I'm gonna go through all of these, select them, and turn them into construction geometry. All right, so now I can come in and I'm going to do an offset from that edge. And I'm gonna be offsetting this by, let's say, 0.25 inches. Switch that to a negative. So the next thing that I'm going to do is come in and fillet all of these corners. All right, and let's make that fillet 0.2. And now I'm going to offset this entire edge again, and I'm going to do a negative 0.035. Offset just to give it a nice line. Okay, great. So now I have some closed geometry here. So I've got essentially 3 closed loops. So I have a closed loop here that I can use for my V-carving. I'm going to add a little bit more detail to this before I exit the sketch. So let's go in here. Let's grab a rectangle tool. We are going to do a center point rectangle. Click here. I'm going to go ahead and click up on my bounding box. Then I'm going to do another center point rectangle and stretch it out until it snaps to this edge here. All right, and now say 3.35, and we'll put this one, grabbing the top and bottom edge at 1.35 inches and hit OK. All right, so with all of this defined, I am going to go ahead and finish this sketch. All right, and what I'm going to do is I'm actually going to extrude and do a cut of these shapes. I'm going to just drag this into my main body. The depth doesn't really matter, and I'm going to hit OK. All right, now the reason that I did that is because I really want to illustrate that Fusion 360 can use both 2D sketch geometry and face pockets in order to create V-carve edges. All right, now the next thing I'm going to do is create another sketch, again, going to the top geometry. And now I'm going to add some text. So let's grab a quick text box here. All right, and we're going to place this right about here. And let's put in some sample text. So I'm going to do the glasses. All right. And a couple of things to call out here. I'm using the Bebas new font. If you'd like to follow along, it is a Google font, so you can download it, but this is your file, so you can use whatever font you want. I've set the height to 0.165, and I've increased the character spacing slightly to 10. I've also aligned this in the center of the vertical and the horizontal direction. All right, and then I'm going to hit OK. Now, in order to line this up correctly, what I'm going to do is I'm going to create a new line, switch it to construction geometry there, and I am just going to set that up that way. And then I'm going to set up another one across this way, just so it's very clear where the center point is here. All right, now I'm going to hit escape to exit that, and I can just click and drag this in order to center up my font. All right, now I can find the center of this box as well, again, by using the diagonal method. So I'm just going to strike a diagonal there. You could also use the midpoint. All right, hit escape. So let's set this up here, and I'm just gonna eyeball it. Doesn't need to be exactly perfect there. All right, and now I'm gonna do finish sketch. So as you can see, I have two things that are gonna be driving my V-carve. One are some face pockets and some face contours in my actual 3D model, and one is a sketch. Now, just want to reiterate that you do not have to have any actual cuts into your workspace. You could drive a V-carve completely off of sketches. In this case, I just felt it would be easier to run a simple extrude than to go back through and trim all of this geometry to isolate the contours that I wanted. So that's why I worked that way. And with that, we are done with our artwork creation. It is now time to move to our next step, which is to set up our manufacturing file. So in order to do that, we are going to first hit save so we don't lose our work. And now we're going to click on the design tab and move over to manufacturing. Now, if you've used Fusion before, but have never done any V-carving, this is all going to look very new to you, but don't worry, we are going to walk you through and you are going to be just fine. So the first thing that we're going to do once we're in the manufacturing environment is we need to create a setup. Essentially, we need to tell Fusion, what are we doing? Are we turning? Are we milling? Are we water jetting? So let's go ahead and create a setup here. The operation type is set to milling, all right? And so based off of that, it has given us 3 tabs here that we need to walk through. I am actually going to start with the stock tab because I want to explain what that is first. Stock is essentially what is the size of the raw material that you are going to be cutting from in order to get the finished size workpiece. As you can see, there are really 2 options here when we're talking about CNCing versus maybe more turning. So for flat hobbyist CNCing, there's really 2 types. Fixed box size, where you're defining the width, length, and height of the stock manually. So I can, for example, type in 10 here, and you can see now that it is going to be stretched out to 10 inches. The other option is to do a relative size box. That is going to create the box relative to the size of the model. So for example, if I set the side offset to 2 inches, you can see that now I have an offset 2 inches in every direction there, and I can set the top offset to 1. Then you can see here in your stock dimensions, this will be the dimensions of that stock box. We are going to come back to the stock box tab, but let's jump back to our setup. Okay, under setup, there are a few different tabs that you're going to, or drop downs that you're going to walk through. First is the machine. So your machine may have some settings already pre-configured in Fusion 360. You can browse through there. I run a Onefinity, so I actually went to their website and they have a Fusion 360 profile that I could download and install, but that is really going to be something that's very specific to your machine. So I encourage you to do some research there before you start V-carving. We've already talked about setup, so we can skip through that. And now let's talk about the work coordinate system dropdown. And this is very important, so we're going to spend a little bit of time here. First thing that you're going to need to do in the work coordinate system is define the orientation of your stock and your CNC machine. All right, essentially what it's asking you here is, what does your machine think positive X, positive Y, and positive Z are? And the way that you're going to do that is you're going to go down to your machine, you're going to set it to jog mode, and you're going to push positive X, positive Y, and positive Z, and make sure that these three axes are aligned with that. All right, if they are not, that is how you are going to start CNCing sideways, or you're going to drill into your table. So very, very important that you set that up correctly. Now you can see in this drop-down menu, there are a few options. I have mine set to model orientation. We started talking about that when we set up our initial file, right? Z-axis up forever, because for my machine, this is positive X, this is positive Y, and this is positive Z, so that's how I model. You may run into situations where you import a file or you need to turn it around so that you are CNCing something in mirror. So you can actually set the X and axis and the Z axis independently. All right, so if you click on that, you can see now I have the option to set what my Z axis is. All right, and now it's going to ask me to set my X axis. So I set it this way. And now you can see that it's set the coordinate system Z, Y, X. And obviously I can change the positive direction by clicking on the tip of the arrow. Now, let's go back to our model box orientation. That's what we're going to use here. Once the model orientation is set, the next important parameter that you're going to need to set is the location of the origin. All right, what it's asking you here is, what does your machine think 0, 0, 0 is? There's a few different options right here. All right, you can use the model origin. All right, so that's essentially saying, did you model it exactly like it's going to be carved? I don't want to use that. Option number 2 is selected point. I can literally select any point as my origin. All right. Option number 3 and 4 are model box point and stock box point. And you can see for both of this, essentially what it's asking me is the 8 corners, all right, the midpoints of those lines, all right, and it's also going to show me the center of my faces. So for example, top center, bottom center, middle center of my model, and same thing for the stock box, all right? So you can see this is the center of that top box, the bottom of the top stock box, and the middle of the top box. So this is the geometric center of my stock box. A lot of different scenarios are going to require different origin points, but I would say the most common are people are going to use the top center, or they're going to use one of the corner points to define their 0. For this example, we are going to be using the top center point. Now, the reason that I jumped to the stock tab first is because I want to make you aware of something that can happen and then can cause you to ruin your file. I have set this relative size box to be a top offset of 1. That's a pretty uncommon scenario. What's going to be more likely is that maybe your workpiece is a little bit bigger than your finished piece. All right, so maybe before you do your V-carve, you're going to run some type of face milling operation. So you need to call that out in your stock. If you do that, you can see that your stock box point and your model box point are really close together. And if you're not paying attention, you can accidentally select the wrong one, and your first CNC pass is going to just destroy the top of your workpiece. So be very careful and always pay attention to what you're setting your origin point to. All right, last thing I want to call out on this tab is you can select what the model is. It's not always going to be just one thing. Sometimes when you're modeling more complicated objects, you'll have different things in the same environment that you'll want to carve at different times. So you can define which bodies you want to include when you're doing this stock box calculation. All right, now let's go back to the stock tab. And for this example, I'm actually going to use a fixed size box. So what we're gonna do is we are going to pre-cut the length of our stock board, our raw material, all right? So I'm going to set the depth to be the same as my finished piece, 3.5 inches. I'm gonna set the width to be 10 because I wanna have some overhang on either side so that I can place my clamps. Actually, let's go ahead and bump that up to 12, just for a little additional safety here. All right, and I'm gonna set the height to be the exact same as my workpiece, 0.375. The reason that I did this is because for this particular example, I want the 0 point of the origin, 0x, 0y, 0z, to be the center top of my stock, which also coincides with the center top of my finished workpiece. And then we're gonna hit OK. All right, setup is complete. Now, one last thing that I wanna call out before we move to the next step is that you can right click on this anytime and edit it. And then when you make your changes, you can just simply hit OK. All right, next step in our VCarve process is to import your tools into your tool library. If you have not done so, I actually have a separate tutorial dedicated to how to install your bits. You can find that video here. And if you have not done so, I highly encourage you to pause this video, jump over, and then jump back. So for this tutorial, I'm going to be using this bit right here. I think it's great. I love this bit. Not super expensive. Love the fact that I can change the blades out. But for this tutorial, I think pretty much any VCarve bit will do. So jumping back over. All right. So now that we've got our tool imported, the next step is to start defining our toolpaths. All of these options here are different toolpaths. Now we are going to be doing a VCarve today, so the toolpath that we are going to be using is the engrave option. Once you click on engrave, you are going to see a very similar dialog box to what you saw in your setup. All right, so I'm going to be walking you through this. First option here is to select the tool from your tool library. So I'm going to go to the Practical Alchemy bits. I'm going to select the Armana bit that I just mentioned and hit select. What you can see is it's going to ask you a lot of different things. Now I actually have some default set into my tool. So let me open the tool library again, double click on that, and then double click on this bit. You can see that over on the cutting data, I have some of these settings preset to things that I use often. All right, so what I can do is I can come in here and from this drop-down menu, I will just set my standard VCarve. The next question you are probably asking is, where do I get this information? And the best answer is to always go to the original manufacturer's website. Oftentimes they will provide the feeds and speeds on their website, which you can download. So you can see when I click on this PDF, I can identify the bit, I can identify the material, and it's going to tell me the key components here. The RPMs, how fast it's going to spin around, the feed rate, how fast it's going to push through the material, and then also how fast it's going to ramp down. And some of the other parameters you can calculate based off of that. So jumping back into Fusion, you can see that I've got my cutting feed rate set to 40 inches per minute, and I've got my ramp feed rate set to 20 inches per minute, and the plunge is also set to 20 inches per minute. Very important thing to call out when you are setting your toolpaths is to pay attention to your spindle speed. Now I'm running a Onefinity hobbyist CNC machine with a Makita router, so my CNC machine does not control the speed of the router. No matter what you put into this box, which could be 1, could be a million, does not affect that speed. All right, so just be aware of that you are going to, before you start your carve, want to make sure that you have set your spindle speed correctly manually for that path. Now, I still like to get into the habit of making sure that I've got that data entered so that when I go downstairs, I'm not always having to remember or go back to the website, right? I can pull up the toolpath and I can see what the spindle speed should be set to. All right, with all that, the next thing is the geometry. What are we gonna cut? So you can see that there is a contour selection here, and I'm going to just start clicking all of the closed contours that I want to include in my toolpath. You can see that they're going to be added to the list as chains. If you accidentally click on something that you didn't want, you just click on it again and it will remove it from the list. And then when you're done, you can move over to the Heights tab. Now, the Heights tab is important because it's going to set up where the machine is going to set the height when it's moving around. Now you can actually hover over all of these and read about what they do. I'll give you a quick breakdown here. Is clearance height is how high the CNC machine is going to move when it's going from path to path. Retract height is how high it's going to go when it's going from contour to contour. All right. Feed height is essentially where it's going to transition from its ramp to its plunge speed. So going from kind of rapid to kind of making sure that it slows down so it doesn't slam into the material too quickly. Top height is the top, and bottom height is the bottom of the tool path. Now, I would say as a general rule, if you're doing a simple 2.5D V-carve on a flat surface, the default options here are going to work out just fine. There are two major scenarios that I can think of where you're going to want to pay a lot of attention to this. Number one is if you are V-carving down in a pocket where you've got a lot of things happening up here, right? You just want to make sure that your retract height and your clearance height are high enough that your tool's not accidentally slamming into, say, like the edge of a bowl, right? If you're V-carving down in the bottom of a bowl, you want to make sure that this retract height is high enough that it's not going to chip off the edges. All right. The other scenario is if your V-carve path would allow you to essentially carve through the bottom of your material, you are going to manually set the bottom so that it will not go past that point. And if that's still confusing, you can jump over to my beginner's guide to V-carving video where I explain that in greater depth. All right, now let's go to passes. So for V-carving, really the options here are, how sharp do you want to take these corners? I've never changed the setting. And the other option here is to engage multiple depths. So will you do all of your V-carving in a single pass, or is it going to step down incrementally, which can be good for bigger pieces to help from chipping. But for now, we are going to leave that toggle off. And the linking tab is not really going to matter for this, although you can set the entry position manually if you need to. So essentially, where is it going to start your tool path? All right, and with all of that set up, we are going to hit OK. Toolpath setup complete. Next step is to simulate, and this is very, very important. You should always, always, always simulate your toolpaths before you export them. What we're going to do now is we are going to turn off the model because we don't want to see it for the moment. And we're going to go over to simulate machine. Now you can see here there are a few different options. All right, I feel like I typically leave all of these on by default. All right, and the question here is really, what is the stock and do you want it to be transparent? So you can see you can change the stock if you want it to be more metallic or more like metal. Right now we'll just use the default ceramic. You can say it's transparency here so that you can actually see the tool going through the side of the workpiece. And we also have the dialog down here in the bottom center. So what we're going to do is we are going to push play and we're going to watch the simulation to make sure that everything is moving exactly as we intended. So there's a few different things that you are going to see here. The yellow line is where it's going to rapid, so that's where it's going to be moving very quickly. The red is when it's going to transition to its ramp speed, and then the blue lines are the actual cutting through the workpiece. And then you can see the green is the area that's cut away. So I'm going to slow this down and we're going to run this again. So let's hit play. All right, and as you can see, where the tool is going to be rapiding down. And then as it starts to get closer to the workpiece, it's going to slow down a little bit. And now it's going to start our V-carve. And I think we got the idea. I'm going to speed it up a little bit. It's going to wrap it over. And get all of our paths. Now, the other thing that we're going to be checking for here when we're doing our simulation, one, to make sure that it's doing what we expect it to do. But the other thing that we're going to be doing is checking to make sure that our machine is not going through the bottom of our workpiece. So essentially, the wider the path, the deeper the bit goes. So we just want to make sure that at no point is our bit going to be plunging through the bottom of our workpiece. Now, this is a very small V-carve, so we don't have to worry about it. But again, it is always important to run a simulation, check your toolpaths, and if you have any issues, right-click and edit those toolpaths. So I just showed you how to create a V-carve toolpath from a face contour. Let's do the same thing from a sketch. So for example, let's turn our model back on for a second. We're going to go back up to 2D contour. We're gonna hit engrave again. By default, it's gonna select the same bit that I selected last time. All right, I'm gonna do my contours and I am going to select this text. Now the cool thing is that if it is still text, it will select it all in one thing. If it's not text, I am actually going to have, and it's just geometry that you've maybe imported from a DXF file, you are going to have to select each of these individually. And in order to create the interior and the exterior of the A, right, essentially you need two closed paths. You need a closed outer path and a closed inner path. And it is smart enough to know what to do there. So with all of that, I don't need to change any of their settings, so I'm gonna hit OK. And right, next step is to simulate. So I'm gonna go over to the simulate path, just slow down, still generating. All right, I'm gonna turn that model off so that it's not occluding. And as you can see, when I hit simulate here, I'm gonna hit play, and it's gonna come in. Oh, you can still see the model. Turn the transparency off. All right, that was a little choppy. Let's run that one more time. All right, so I check my simulation here. So it's gonna come down. It's gonna start cutting these edges. Speed it up a little bit. And transition into the side view here. Transparency on so I can check. And everything is looking good to go. All right, so the next step in our vCarve is to post-process and export our toolpaths. All right, so now that we've got our toolpaths set up, we now need to export them into machine code. If you are running the hobbyist version of Fusion 360, you are not going to be able to export all of your toolpaths into a single file, even though you're using the same bit, right? Every unique toolpath that you create is going to have to be exported as a single file, and you're going to have to run them individually. That can be a hassle. You know, if you've got lots of little things, I would not recommend you creating 18 different engraves. But at the same time, if you have something very complicated, it can be very hard to click on everything and make it all processed as part of one path. So trade-offs about, for this example, while I could have selected all of these contours as part of a single engrave path, I wanted to set it up as two specifically so that I could show you what to do. So the first thing I'm gonna do is I'm gonna click on this toolpath, and then I'm gonna come up here to post-process. Click on that, and it's gonna give you some options. It's gonna tell me where to export, this is my jump drive. It is going to suggest a name, but I'm just going to go in here. And typically what I like to do is I like to call this something big. So like safety glasses. And then I like to give it a numerical code like 0, 1. That way I know that this is the carve that I want to run first, and then that's the file that I want to run second. All right, there are some other options here in terms of configuration. I don't touch any of these for my specific CNC machine. I know some people have to select things like the output the M6 or to open the NC file editor after it posts so that you can add stops and things like that. The only one that I would call out is to change the units if you prefer metric or SAE. Here, all right, so I'm just gonna use the document units, that's fine, and we're gonna hit post. All right, then once it has posted, you'll get a little pop-up down here, and I'm gonna do the same thing with it. I'm gonna select it, I'm gonna hit post process, and I'm going to label it safety glasses 2. That way I know that this is the one that I'm gonna run second, and hit post to export. All right, and with all of that, we are done working in Fusion 360. So you can grab your jump drive and head down to the CNC machine. And I am gonna be walking you through that entire vCarve process in the next video. So if you enjoyed this video and found it helpful, please hit the like button. If you have any questions or issues, throw those in the comments below. And as always, hit the subscribe button if you wanna stay up to date as I release new content. Thank you so much for watching, and I will see you in the next one. And don't forget to hit save.